this is the temperature at the time. This is the T ambient is the temperature of the room. T object is the temperature of the body at a certain given time. Then we'll use E, and then K is our decay coefficient, and T is time once again. So we're gonna plug in the values we already know. We're gonna start by using 75 for T because this was the resulting temperature after an hour after the body was found. So 75 equals to, the room was kept at a constant temperature of 70 degrees. So we're gonna put 70 plus, and then at 6 o'clock, the body was 80 degrees. So we're gonna put 80 minus 70. And then we don't know K, and then we know 1 hour passed. So we're gonna plug in 1 for the other T. First thing we wanna do is solve the parentheses. So this will turn into 75 equals 70 plus 10 E negative K1. And we know we can basically eliminate this 1 because K, negative K times 1 will be negative K. So we can scratch that out. Now we can subtract 70 from both sides of the equation, and that's gonna leave us with 5 equals to 10 E raised to the negative K power. We're gonna divide by 10, and that's gonna leave us with half. Half equals to E negative K. In order to isolate E by itself, we'll log of both sides in order to eliminate E. So basically we're multiplying by the natural log. So that's gonna give us the ln of 1/2. So we're taking the natural log of 1/2, and that's gonna equal negative K. So when you plug that into the calculator, you're gonna get negative 0.693 to equal negative K. And if we wanna go a step further, all we gotta do is eliminate the negatives, and K is equal to 0.693. Next step, we're going to be determining and discussing the approximate time elapsed from death to when the body was found. So for this, we are going to use the same formula and just plug in the values we now know. So we're gonna use 80 degrees because that's the temperature when the body was found, and it's equals to 70, which was the constant temperature in the room. And then we're going to use 98.6 because this is the standard body temperature for an alive human being, and we're gonna subtract from 70. And then we now know negative.
It could be anything.
Okay, so, and now since we now know what the value of negative K is, it's going to be negative 0.693, and we're going to leave T as a variable because that is what we're figuring out. So we want to isolate T. So now let's do our subtraction in the parentheses. This is going to be 80 equals 70 plus 28.6 E raised to the negative 693 times T. Now we're going to subtract 70 from both sides of the equation. 10 equals to 28.6 E raised to our K times T. Now we're going to go ahead and divide by 28.6 in order to to get E. This is going to leave us with 0.35 is equal to E raised to our K T. So now in order to get rid of our E, we're again going to take the natural log of both sides, leaving us with the ln of 0.35 equals to negative 693 T. Now we're isolating T and dividing by negative 693 on both sides, leaving us with 1.5 equals 2T. So 1.5 hours passed from the time of death to when the body was found. Since the body was found at 6:00 p.m., we're going to go back an hour and a half to 4:30 p.m., giving us the approximate time of death.